Hey guys, Mrs. Zimmerman here. We're going to talk about graphing today. Make sure you have your Cornell style notes set up on the right hand of the page. Take notes along the way, and if I ask you to pause and write something down, please make sure you do that. Alright, so there are three main types of graphs you will see in a science classroom. The first type of graph is called a line graph. You've probably seen these in math class before. If you look, line graphs are going to be data that is continuous, and for the most part, line graphs are going to be used when we're talking about time. So if we look at this graph here, we are looking at a time frame by decades. We could have a time frame of seconds or hours or minutes or any way that we measure time. You would use a line graph. When line graphs are used, we would connect them with a straight line. The points are connected with a straight line. If you are hand graphing, lines should be connected with a ruler. And the reason we use line graphs is to show how the independent variable affects the dependent variable. So looking at this graph, our independent variable is year by decade, and our dependent variable is the number of people in thousands. So what we're trying to see in this graph is how does the population of Wildwood change over a 100-year span. And by looking at this graph, what do you see? What can you infer that is happening to this population over 100 years? I want you to pause and write down what you chose. Alright, you should have said that over a 100-year span, the population increased generally. We started off with a population of about 10,000 and ended with a population of 50,000. So there was a increase of around 40,000 people. And over that time period, we saw two decreases from 1920 to 1930 and 1960 to 1970. Now you could look at, what was happening in Wildwood at that time and try to figure out why there was that decrease there. All right, second kind of graph is called a bar graph. Data is not continuous like a line graph. In a bar graph, we usually use these to compare data, and there's going to be different categories. So if you look, we're trying to compare excuse me, the diet type for fish. So we have herbivores, we have piscivores, and we have omnivores, and we're trying to compare that data. If you look, this is a pretty nice bar graph because it gives us numbers at the top. Those numbers are going to be able to tell us exactly what that data point is, because if you look at this bar here, 25, you look, it's not exactly on 24 and it's not at 28. So if that number was not there, you would have to guesstimate. But putting those numbers there allows you to really know what those data mean. Okay, pie graphs is the third kind. You might have heard them called circle graphs. Pie graphs usually are only going to be showing parts of a whole or percentages, and if we would add all of the different groupings up, it should reach 100. For the most part in biology, we will not be using pie graphs, but I wanted to show you what they would look like and why you would use them. Alright, so we have a couple different descriptions here, and we need to figure out what type of graph we would use. Alright, so the example, the amount of each color of M&Ms in a bag. We would use a bar graph for that because we are comparing the different colors. Okay, we're not showing continuous data over time, and we aren't looking at parts of a whole. So a bar graph would be the most useful for this case. Alright, there are 5 other ones. I want you to pause, and I want you to write down what you think or what type of graph you think we would use for each of those examples. All right, let's see if you were right. So for number 1, heating a pan of water over a period of time. So I see time here. I'm going to probably pick a line graph for that one. Number 2, shows number of students earning A's, B's, and C's. Should have picked bar because we are comparing the numbers of A's, B's, and C's. Number 3, measuring the percentage of each gas in the air. This is your key word here, percentage. You should have picked pi. 4, shows the percentage of allowance spent on different things. Percentage, key term, should pick pi. And then for number 5, shows height change over 15-year period. 15 years, that's time. You should have picked line. All right, so if we are setting up a graph, there's this nice little anagram that I like to use. It's called tails. That word, tails, is going to show you what you need for every graph. T stands for title, A for axis, I for interval, L for labels, and S for scale. Any good graph has to have tails. If it's missing any of that, then it's not considered a good graph. Now there's one more thing that this should have, which would be a key, but not every graph has a key, so that's not included in the tails. All right, tails, T for title. A title should be written up at the top, and it should contain both your independent and dependent variables. Your title should be descriptive enough that whoever looks at your graph knows exactly what you were testing. Okay, so a title should include your independent and dependent variables. A stands for axis. It's the same thing in math class. This is your x-axis. This is your y-axis. Now in science class, we are going to plot whatever our independent variable is on the x-axis and whatever our dependent variable is on the y-axis. To figure out how to scale your axes, you need to figure out which scale is most appropriate for your graph or for your data that you have, and you need to make sure that your graph takes up the majority of your paper. If you have a piece of paper that is this big and you are only using this much of the paper, you aren't utilizing your space, and all of this data is going to be cramped into a little tiny spot. So we want to make sure that we use all of the available space that we have. So if we look at this data set, we were comparing these different singers and the number of teachers that liked those singers. So to figure out your scale on how to set up your axes, you would look for your lowest number to your highest number. So in this case, our lowest number is 2 and our highest number is 22. So the scale would be from 2 to 22. And then you could set up your axes so that you include that data range. Now you don't always have to start your axes at 0. You can start it at another number if you need to. All right, the I stands for interval, and that is basically figuring out what we are going to count by on our axes. Are we going to count by 1s, by 2s, by 5s, by 10s? You're going to want to pick an interval that makes most sense for the data that you have. So in this case, we probably aren't going to want to count by 10s or 5s, we aren't going to want to count by 10s because our lowest number is 2 and our highest number is 10. That's not going to give us the best information. So to figure out your intervals, you should subtract and divide by how many intervals or spaces you have on that graph, and that's going to be able to help you figure out what you should count by. And in this case, let's just count by 5s. Okay, and that's how it would be set up. So if you look, we only had 1, 2, 3, 4, 5 spaces or 5 different rows on here. So we had to count by 5s in order to fit 2 to 22 on here. Okay, Okay. And then the last thing that you need is L for labels. You need to make sure that you have your y-axis label, and you need to make sure you have your x-axis label. All right. One other thing that I like to have you remember is dry mix. It's, going on through the year, it might become difficult to remember which variable you plot on which axis. So if you remember dry mix, it'll help you. The dependent or the responding variable you put on the y, the manipulated or the independent variable you put on the x. Keep that in mind when we're working through. Sorry, I'm sick. All right, what will be expected of you? So anytime you make a graph, each graph is going to be worth 18 points. 2 points for the title, 2 points for the x-axis title, 2 points for the y-axis title. For the labels, the scale's appropriate, the interval's appropriate. If you're using a ruler, and that you picked the appropriate type of graph to use based off of your data. All right, so I want you guys to put this all together. You have received a blank graph. I want you to cut it out and glue it down into your notes. And I want you to create a graph of this data here. You're going to need to figure out which one is your independent, which one is your dependent, so that you know where to plot this data. And that's your homework for tonight. Tomorrow when you come in, we will be looking over your graphs and seeing if you used tails and dry mix to create this line graph appropriately. All right, guys. Have a good night. See you tomorrow.